Okay, we're going to do system of equations, linear equation applications. We're going to do three types of problems. So as I go through the problems, the first thing I'm going to do is set them up. And then I'm going to go back to each of them and actually solve them. So if setting up is the hard part, you could focus on that. And if you want to solve it, we could do that as well. So this first problem is going to be a purchase problem. Okay, so this is going to be number 1. A woman bought some large frames for $10 each. So I'm going to start highlighting right away. Large frames, $10 each. Some small frames for $6 each. Small frames, $6 each. She bought 13 frames in all, so that's not large or small. And that was $90. Find how many of each type she bought. So the two variables, I mean, I kind of already see it just in reading it, are going to be the large frames and the small frames. So for small frames, I'm going to use X. For the large frames, I'm going to use Y. So now that I have my variables, I can start to put this together. Large frames are $10 each. That means one large frame is 10. Two large frames is 20. Three large frames are 30. So what I'm doing is I'm taking 10 and I'm multiplying it by Y. That's how I'm going to figure out this cost. So for the small frames are $6 each. It's the same concept. So it's going to be 6 times however many small frames I have. And I'm going to add that together. Now the key is, this is a cost equation. $6 times however many I buy. $10 times however many I buy. If I'm adding dollars and dollars, this has to give me a total dollar amount. That total dollar amount is $90. That's the total that was spent. So the key in writing these is really understanding what types of equations you're writing. So we have a cost where we're adding up dollars. So we have to get dollars. The only thing that we haven't, the only other thing in here that we haven't used is the 13 frames. So if she bought 13 frames, that's a total. 13 frames means if I take the amount of small and I take the amount of large frames and I add those together, that's going to give me 13 total frames. So that's how we set up these problems. Yeah, that's how we set up this first purchase problem. And then you would solve it in any method that you want, substitution or elimination. So let's look at this number 2 problem. So this is a daily charge problem. So Primo Car Rental Agency charges $27 per day plus 10 cents per mile. Ultimo Car Rental Agency charges $18 per day plus 70 cents per mile. Find the daily mileage for which these are the same. Okay. So I'll jump straight to the end. If it says they're the same, that means they're equal. That means I want to know where the Ultimo is equal the Primo. So my equations are going to be separate for this type of problem. So I'm going to have one equation for the Primo car rental. So it says that they charge $27 a day plus the 10 cents per mile. So these per pieces means we're multiplying, right? So if it's $27 per day, one day would be $27. 2 days would be $54. 3 days, and you just keep adding. The tricky part here is they're asking for the daily mileage. That is your variable. So the mileage is what you're looking for. And it's telling you daily. So this is also telling you that you're only doing it for one day. So it doesn't matter how much it costs. Well, I mean, it does matter, but we're not multiplying that 27 by anything. So that $27 is one time for the day, and then we are adding 10 cents per mile, so times, let's say, X. I don't know what this answer is going to be. So this is equal to Y, right? That's going to be the cost for Primo. So the Ultimo is going to be similar. So I know it's $18 for the day, and I want to know the daily mileage. I'm going to be adding 70 cents per mile, and that's going to give me the cost at the end. So those are our variables. So we have our X is our mileage. And in this case, our Y is actually the cost. And then you could solve this using elimination or substitution and going through it that way. So we got one more example to explain. So this is a cost and revenue problem. So given the cost function and the revenue function, find the number of units that can be sold to break even. This tells you everything that you need to know. If you're breaking even, that means your cost and your revenue have to be equal. So this is actually the easiest one because they tell you everything that you need. So we need to figure out when the cost of doing business is the same as the amount of money that you bring in. So we solve. So we subtract the 14. 42,000 equals 3x. We divide by 3. X is 14,000. So what is X? X is the number of units that must be sold. So 14,000 units must be sold. We answered the question. What if they ask for the Y value? So this is saying the cost and the revenue. So if we wanted to find the Y value, it's asking when it's breaking even. So C of X and R of X are essentially both going to equal, well, no, you would have to take that X and plug it in to find that. They're going to be the same regardless of what you do, but you would do the 14,000 and the revenue is probably going to be easier. And because it's revenue, it's going to be a dollar amount. So if they did ask for something else, that's how you would find the other value. So now we'll go back and we'll solve the other two equations. So the daily charge problem, to solve this one, the easiest way to do this is going to be substitution. And the reason it's going to be substitution is we have both of these equal to Y. So I kind of already have my expression right here, right? So if Y is equal to 27 plus 10x, I could just take that and substitute it in for this other Y. So it's going to be similar to the last one. So it's going to be 27 plus 0.10x equals 18 plus 0.70x. I'm going to subtract the 10 cents and move that to the right. I'm going to subtract the 18, move that to the left. So 9 equals 0.60x. And then we're going to divide by 0.6. And this is going to give us our answer. And that's going to give us 15. So x is equal to 15. It's a word problem. So we said over here that x is the mileage. So 15 miles. Find the daily mileage for where they're the same. 15 miles, and that would be for the same cost. If they asked for what the cost would actually be, then you take this 15 and you plug it in. And you solve for y if they ask for the cost. Okay, let's go to the first one, the original, with our small and our large frames. So we have our two equations. We can solve this in either way. So because we're doing all these different methods, I'm actually going to do it as elimination, just to change things up. So the small frames are x, the large frames are y. So we can move some of this. So to eliminate, remember we need the same coefficient, but they have to be opposites. So I'm going to multiply the bottom equation by negative 6. I'm going to do it on the left side and the right side. So the top equation is going to be 6x plus 10y equals 90. The bottom equation is going to be negative 6x minus 6y equals negative 78. I'm going to add these together. 6 minus 6 is 0, so I'm eliminating the x's. 4y equals 12. So y is 3. What's y? Y is the large frames. So this 3 means 3 large frames. The question is asking how many of each type. So we are not done. We do need to do the work to figure out what the x value is. So we could plug it into either one. I'm going to plug it into the first one. 6x plus 10 times y, which now I know is 3, equals 90. 6x plus 30 equals 90. Minus the 30. X is 10, which means there are 10 small frames. So that's the purpose of labeling these. I know the small frames are x. So when I get x, I know my answer is going to be that many small frames. So hopefully these word problem types will help you navigate some of those problems that you get.